than a repository of information, as massive of that volume.
Yes, analytics may not be.
What is next generation cognitive enterprise? Answers today from my conversation with Joe Selle, Enterprise AI Transformation with IBM. Joe, welcome.
Thank you, Bob.
Got to think this is more than a buzz term. Let's start by saying just what is the cognitive enterprise?
It is, you're right, Bob, it is more than a buzz phrase. A cognitive enterprise is a company that has decided to invest in data and technologies that would allow its workers to do their jobs better than before. Artificial intelligence is another synonym to cognitive. So an artificial intelligence enterprise is one where there are vast quantities of data that are available for the workers to manipulate with tools that allow extraction of information from that data.
So I think cognitive, that makes me think of thinking, which leads to, as you say, artificial intelligence. Are we talking about a capability? It's not exactly that it mimics the human brain. It sounds like it's doing something that humans are incapable of doing because of the massive data involved. Is that the case?
A little of both. It is providing the human the ability to handle and manage data in quantities that they couldn't have before. So that's an enhanced capability. It's kind of like taking a person and making them a super professional. If you are a supply chain planner, for instance, and you are operating within a cognitive enterprise, so a company that has been investing in data and the tools to extract information from that data, you're going to be a twice as good supply chain planner. If you are a procurement professional, you're going to be a twice as good, or maybe it's 4 times as good negotiator, because you know things about the price movement in the future. You have some models at your fingertips that are telling you whether the prices are going up or down and by how much, and whether you should be a hard bargainer or not. So whatever your job is, and it's not only just supply chain, by the way, it is finance and human relations and asset management and all of the functions of a company. If those functions have AI or cognitive capabilities around them, the people doing those jobs are doing a better job. They're doing it faster and they're doing it more accurately.
But again, in the early days of AI, we used to talk about AI as creating what were then called expert systems. In other words, replicating a human expert's experience. What you're talking about goes beyond that. This is more than mere experience. This is talking about a mass of data and the sort of thing that may help a human in his or her job, but also does something that human is incapable of doing. So it's a combination of the two.
It is. And let's go back to the expert system idea, because that was big when 20 years ago or something, a long time ago. Now think about a cognitive or an AI system as being a digital assistant. So it's an entity, if you will, that resides on my smart device, on my telephone, and I can ask a question to this device. I can ask the question in natural language. I don't have to be very specific. I can say, geez, there's a hurricane that's about to hit North Carolina. Are any of my suppliers at risk in their operation for being shut down? And the system will come back, and we have this capability, by the way, this is not hypothetical, and it will say, yes, there's a Category 4 storm that is coming towards North Carolina. It's got a such and such probability of being a Category 3.5 by the time it makes landfall, and you have 3 suppliers there, and those suppliers are preparing orders, preparing to ship parts out that will be incorporated into a certain order. So I can end-to-end connect all of these databases and get a vision on what will be the impact to my customers, which is really what I care about. Mm-hmm. I care about the storm, the suppliers, those suppliers not being able to ship me my parts, me not being able to assemble and manufacture my large computer for my end customer or for my channel partner. So I can get the implications of the storm at a question, by asking my device a question or by typing it in.
So more than a repository of information, as massive of that volume of information might be, we're talking about a system that can do more than just take in information and then spit it back out at you. We're talking about, I guess you would even call it cognitive analytics. Would that be the proper term for it? Is that what you were just telling me about?
Yes, analytics may not be the most current term for it. We would use, so the hierarchy of terms would be visibility, prediction, and prescription. So the visibility is getting the information to a place where you can draw a conclusion from it. The probability is making a prediction on where you think a price is going to go, in my example of the procurement specialist. And a prescription is telling that procurement person, advising them what to do. What's the highest probability strategy that will win them the most? And so don't think of it as analytics, think of it as prescription, really, and helping to advise the worker on the next best action.
Well, when we get to the prescription phase, what then does the human do? Do they just blindly go along with what the system is telling them, or do they say, based on my own human judgment, I'm not going to go with that? I mean, what % of the time are you following what the system's telling you to do?
Well, that's interesting. What we've found, because we've been building and deploying cognitive systems throughout our functions, like I said, supply chain, but also all the other functions, we have a pretty big body of experience now, and it turns out that people don't trust the computer, especially when it gives them some kind of a challenging answer. For instance, if you're planning safety stock and you're a good old-fashioned supply chain person, and you thought you needed 8 days of safety stock on a certain part to make sure you're never going to run out. Well, we actually used some very sophisticated modeling, and we were able to tell that same person that you only need 2 days of safety stock. And that would save X hundreds of millions of dollars in our inventory holding costs. The person doesn't always trust the computer blindly. In fact, they usually don't.
I don't blame them. That's a scary thing to say.
It is. They have to be convinced.
Yeah.
So we've learned that we give an answer to a question that's being asked, and we give the probability confidence in that answer, and we give the reason why we came to that conclusion. So when you give that background information, it turns out that the prescriptive advice is more closely followed. But I would say that nobody blindly follows the computer. That's not.
But it's not a black box. It doesn't just come out with a recommendation and say, trust me. You're saying that it actually is backing it up with the as you say, the probabilities and the like, which helps.
It will, yes.
Helps
And it will also give you options. It will say that given this situation that you're describing, there's an 85% chance that this is your best next action. Mm-hmm. Then it'll say, but there's a 60% chance that this is your next best action. And it'll give you 2 or 3 opportunities to think about. So you, as the decider, need to think about these options. You need to use your own cognitive capabilities and say, actually, it's the second option I'm interested in computer. So tell me more about that one. Tell me more about option 2, where you said that there was only a 60% chance. What if I did this? Would that improve the odds of this being a successful strategy? And then you'll get an answer.
What about,
so you go back and forth. It's really a thought partner.
Yeah. What about the question of, does the system get better? We hear the term machine learning, which implies that, in fact, the machine learns, that it gets better and more accurate in its recommendations over time. Is that the case?
It is. The fact is that machine learning is really the ability of the computer to understand and see patterns in data. So if you give the computer a block of data this big, it's going to see certain things. If you give the computer a block of data that's twice as big, it's going to be able to see more. And what that means is you're teaching the system with more historical data or more breadth of data. You're giving it more inputs to draw conclusions from. And it will update its answers according to the new data that you're presenting to it. And there's 2 forms of machine learning. There's a supervised and there's an unsupervised method. The unsupervised is a little bit more cutting edge. The supervised is where I can take your expertise as a SME, a subject matter expert, and you can train the system. And that's supervised learning. And unsupervised learning means that I can just take some tools and sift through vast amounts of data, and I can draw conclusions and learning from that in a more automated manner. That's very powerful, but it's still a little bit more cutting edge.
Tell me about IBM's implementation of this cognitive enterprise data lake. Is that what we've been talking about here?
That's part of it. That is a very important part of it. Think of it as a pyramid, if you will. I know you just asked me about a lake, and now I'm saying think about a pyramid, but get over that. Think of a pyramid where the bottom of the pyramid is the data. And this is this vast amount of data that I keep referring to. It's unstructured, it's structured, it's batch data, it's streaming data from Internet of Things devices that you may have deployed across your network. It's all kinds of data. Then on the middle layer are some tools that organize that data, and they bring structure to it so the computer can ingest it, because the computer actually can't ingest unstructured data. It needs to be structured. And then on top is where the applications and solutions that the users, that you and I will actually touch, go. So you asked me what's up with the data lake, and I said that's where think of that as the big repository of data that this stack is built upon. And at the top is the application that needs that data. It feeds on that data, or it will not be able to give you any kind of additional insights.
To what degree is what you're telling me now aspirational versus reality? How much of this is actually in practice and happening right now?
Well, I am privileged to be working at a company, IBM, that has been investing in this area, literally since the 90s, when we created Deep Blue computer that eventually beat Garry Kasparov, the Grand Master of Chess at the time. Then the next challenge we tackled was the Jeopardy game, which allowed us to go into some new area with respect to natural language understanding and speed of processing. And then that was 2011. So we've been pouring research dollars into this question for a long time. Now we are deploying these tools that I'm describing to you, and most of the things I've described are really in deployment within IBM right now. We have a data lake. We have the ability to structure that data, and we have a portfolio of solutions that reside on that data that are making the jobs of human resources professionals, procurement, supply chain, finance, and the like, helping their jobs. So we've been envisioning solutions, building and deploying and tackling all the normal change management issues, like the people that don't want to listen to what the computer is telling them because they don't trust it, or it threatens their job. So we've sort of been tackling this on a technology and an organizational and a data vector for, I could say 20 years, and I wouldn't be inaccurate.
Now, you have recently, as I understand it, expanded your own brief beyond supply chain, and some of the applications and the functions we're talking about here do, in fact, range throughout the organization. Talk a little bit about how wide-ranging this is.
Very exciting time to be in AI and cognition within IBM, because although supply chain and procurement were the first adopters within the business functions, the back office business functions of IBM, since then, it has expanded to, I think it's 19 or 20 domains, and a domain would be a functional area like finance or sales or marketing or any of the normal functions that you would think of make up a business. So one example of a very impactful solution we have is called Cognitive Pricing Recommendation Engine. And this we deploy to our salespeople in the field, and it lives on their smartphone device. And so when they're discussing a bid with a client, they can put the factors of the bid into the system, and the system will return them a optimal price that should be charged for this. And it does two things. It looks at all of the times that a similar system has been bid over the last 18 months and whether it was a win or a loss. So it's establishing a demand elasticity curve at a given price for something that's being sold to an outside client, and it juxtaposes that curve with our needed profits based on the costs that we're incurring when we build a computer or we make a piece of software. And so these two pieces of information are coming together in real time, and the salesperson has the price on their phone. They can refer to it, and they can just be much better bargainer, and they can find a fair price. And this has been deployed in a stage-wise manner over the last 2 years across geographies and product sets. And wherever we put it in, we're finding that the win rate is improving and the profit dollars are improving. And all of the metrics that we care about are improving. And the customers like it as well because it compresses the timeline of all this.
Yeah. Amazing how far we've come, and I know we have a ways to go, but it's really exciting to hear about the cognitive enterprise at IBM, Joe. So thank you so much for helping us to understand what's going on out there.
All right.
Thanks a lot for being with us.
Thanks, Bob. My pleasure.
I have been speaking with Joe Selle of IBM. Thank you very much for watching.